Okay, welcome to the Unit 8 review, where we're going to cover this, and then you can refer to the solutions that I have posted online as well, or if you need to kind of listen to a walkthrough on how we're going through that. First and foremost, I would like to start by making sure that we're able to produce both of these things to, on Thursday when you take your test. You won't have you're going to need to fill it out. You don't have a spot to do that on your test, so you'll have to kind of sketch it out, and we're going to use this on when it's applicable. And then we also have our all students take calculus, if that helps you determine what signs are if it's positive or negative based off the quadrants. And then you also want to make sure, I would like to say I'm going to remind you, but today during the quiz I forgot, you need to make sure that you are in degree mode when you're doing this. Okay, so let's start off with problem 1. It says, list all angles from the unit circle where the sine of theta is 1/2. Well, we do need to understand that the sine is talking about the y values. And if we look at our unit circle that we should have already created, we can see that that happens at 30 degrees and 150 degrees. Or sorry, we don't see that that's 150 degrees, sorry. We see that occurs at 30 degrees. And so the other part where that's going to also be 1/2 is, remember, this is going to be 1/2 at all of these where they have that same reference angle of 30 degrees, right? So like when we come over here, this would be 150 degrees. Oops, sorry. That would be 150 degrees if we were to look at where that one was. This one would be 210. This one would be 330, going all the way around to 330 degrees. They all have that same reference angle of 30 degrees. So we want to trace this back down to that first quadrant. Because this says it's positive 1/2, we're going to strictly be in at 30 degrees and 150 50 degrees. Or we can also say that is pi over 6 radians, and what is that? 5 pi over 6. Okay, what do we know about tangent of 135 and tangent of 315? So where is that? Let's see what tangent of 135. So where would 135 be? 135 is going to be in quadrant 2. So 135 degrees. That'd be this would be a reference angle of 45 degrees. Okay, so that means that the tangent over here is going to be y over x. So tangent, once again, is always y over x. So I know that the tangent over there at 135 degrees is the square root of 2 over 2 divided by itself. So this is going to be, the tangent of this is going to just equal 1. But because I'm in quadrant 2, this is all students take calculus. So the S means only sign is positive here. So if I'm in quadrant 2, this is a -1. So the tangent of 135 degrees is -1. So I want to think about where is 135 degrees located at so I can get my sine. Then let's trace that back to our actual reference angle and use this information from quadrant 1. Same thing when we look at 315 degrees. That's going to be down here in quadrant 4. So that the reference angle for that is 45 degrees. So down here in quadrant 4, I know that my answer is going to be 1. But because it's in quadrant 4, cosine's the only thing positive, so tangent's going to be negative there. So what I know about these, they're the same. Both are -1. So the sine of theta is greater than 0 just means that it's positive. Tangent's greater than 0 also means that it's positive. In what quadrant does the terminal side lie? Well, sine is positive, And sine is positive in quadrants 1 and 2. Tangent is positive in quadrants 1 and 3. So where are they both positive at? That satisfy both of these conditions? Quadrant 1. Oops, still have one more. If cosecant and secant are opposite signs, in what quadrant would the terminal side of theta lie? Okay, so here we have cosecant. So cosecant is positive here. So it's positive here, which means cosecant is negative here. Cosecant is positive here. And cosecant is negative here. Secant is going to be positive here, but it's going to be negative here because the reciprocal is cosine. Oops. Secant's going to be negative here. And cosecant's going to be positive here. Or secant's going to be positive here. So this says if cosecant and theta are cosecant and secant are opposite signs, in what quadrants could the terminal side lie? This says quadrants with an S, possible S. So now we're just looking at these. Quadrants 1, they have the same sign. Quadrants 2 and 4, they have opposite signs. So this would be quadrant 2 and 4. Okay, this says this is the calculator portion, but you really shouldn't need it. Maybe for the Pythagorean theorem. This is a non-unit circle one, but we want to find the value of all 6 trig functions. So I'm just going to say, sine, cosine, tangent. Let me go ahead and write this all out. Cosecant, secant, cotangent. Okay, so given the point 8, 15, that's going to be in quadrant 1. I go over 8 up 15, I'm going to get something like this. So the first thing we want to do is we want to draw a reference triangle. We're going to label this theta, and then let's label the parts of that triangle. So I know that this point is 8, 15, so when I talk about the sides of the triangle, the x is going to be 8, the y is going to be 15. I can label tangent here right now if I wanted to. So tangent here is opposite over adjacent. So with respect to that, that would be 15 over 8. And if I know that that's 15 over 8, then the cotangent has to be 8 over 15. I can't find the other 4 until I find the hypotenuse. So we can find the hypotenuse by using Pythagorean theorem. So I'm going to go 8 squared plus 15 squared equals c squared. I'm going to call that my hypotenuse. This side comes out to 289. If I take the square root of all of that, I get 17. So I'm going to go back and label my triangle, and now I'm going to fill in the rest of this. So with respect to theta, we have opposite over hypotenuse, so the opposite side is 15. So that would be 15 over 17. If I know that, then I know that the cosecant, the reciprocal, is just flipping those. And the cosine is adjacent over hypotenuse, so 8 over 15. The reciprocal secant is 15 over 8. Well, I did something silly. Sorry, those are wrong. Cosine is adjacent over hypotenuse. So that would be 17 there. Okay. Given the point 1, negative 2, find all 6 trig functions. So same thing again, same type of problem. We have sine, cosine, tan. I'm going to write this as cosecant, secant, cotan. And the point 1, 2, if I go over 1 and down 2, that's going to be in quadrant 4. I'm going to draw my reference triangle. Here's theta. I'm going to label what I can. This point is 1, -2. So my y is 2, that's 1. Once again, I can label tangent here again. So the tangent is opposite over adjacent, so 2 over 1, which is 2, which means cotangent would be the reciprocal of that, 1 over 2. And we do need to make sure that we pay attention to what quadrant we're in. Cosine is the only thing positive in quadrant 1, or quadrant 4. So my tangent, sorry, should be -2 and -1 over 2. My sine and cosine, I'm going to have to use, and the secant and cosecant, I'm going to have to use Pythagorean theorem. So I'm going to say 1 squared plus 2 squared equals c squared. That would give me 5. So c squared equals the square root of 5. C equals the square root of 5, I'm going to go ahead and label that here. This is the square root of 5. And now I can go and label these. So sine is opposite over hypotenuse, and we also know that sine is negative in quadrant 4, so that's going to be -2 over square root of 5, which would mean the cosecant is negative square root of 5 over 2. The cosine is adjacent over hypotenuse, and we know that cosine is positive in quadrant 4, so 1 over square root of 5, and then this would just be the square root of 5. Okay, I did not rationalize my denominators here. I think that that's more so when you're looking at tangent around the unit circle that we need to know that. Okay, find the exact value of each of the following. So sine of -45 degrees, we can either find a coterminal angle, and we can add 360 to that. Either way, I don't really care. Like, if you understand, if the negative sign means we're going to go clockwise, that means we're going to go down this way, and we're going to end up here, like in the fourth quadrant. But if we add 360 degrees to that to get a coterminal angle, we would end up getting 315 degrees, which obviously is in quadrant 4. So sine of 315 degrees, we can think about it that way. Either way, our reference angle here is 45 degrees. So if we have the unit circle drawn, we're looking right here, and the y value of that is going to be the square root of 2 over 2. And cosine is negative in quadrant 4. So, sine is negative in quadrant 4. Cosine's the only thing that's positive in quadrant 4. Let's go on to the cosine of pi over 3. So cosine of pi over 3, cosine's talking about our x. That's easy. That's in quadrant 1. Once we have that, we can look at that. Here we have the tangent of pi over 2. So we do need to remember tangent is y over x. So if we have quadrant 1 labeled, 1 divided by 0, anything divided by 0 is undefined. Cosine of 150 degrees, that's going to be in quadrant 2. The reference angle for that is going to be 30 degrees. So I'm going to be referencing this information right here. And I do need to make sure that in quadrant 2, remember sine's the only thing positive. If I'm finding cosine, my answer is going to be negative. And so the x value of 30 degrees is going to be square root of 3 over 2. The tangent of 225 degrees, it's going to be down here in quadrant 3 somewhere. So how far is 225 degrees away from the x-axis? It's 45 degrees, so my reference angle is right here again. If I'm looking for tangent and I'm in quadrant 3, my answer is going to be positive. So your tangent at 45 degrees is always just going to be 1 or -1, depending on what quadrant you're in. So the tangent of 45 degrees is 1. Any other angle where the reference angle is 45 degrees, you need to think about what quadrant we're in. But the square root of 2 over 2 divided by the square root of 2 over 2 is just 1. The sine of 5 pi over 6, that's almost 1, so that's going to be in quadrant 2. So I'm going to keep this labeled. This would be like 5 pi over 6. The reference angle for that, remember, is just pi over 6. I drew that too high. Let me get rid of some of this stuff. So remember, if this is 5 pi over 6, almost 1, the reference angle is just ignoring that what's in front of the pi to give us the pi over 6. And so I'm looking for the sine. So this is the sine of pi over 6 is 1/2. And what quadrant am I in? I'm in quadrant 2, where sine is positive. So that's just positive 1/2. Okay, this is kind of getting away, I think, from the unit circle a little bit. But let cotangent equal 5 over 12, where theta lies in quadrant 3. Find the exact value of sine of theta. So I'm going to first label a reference triangle in quadrant 3, and I'm going to automatically rewrite anything as a reciprocal as this. Just because I'm more familiar with that. And then thinking about tangent, what does tangent mean? Tangent is opposite over adjacent. That's the SOHCAHTOA. That's the TOA part, opposite over adjacent. So this is opposite, this is the adjacent side. So opposite of the angle theta, which I'll label right here, we're going to say that's 12, the adjacent side is 5. So to find the sine, sine is opposite over hypotenuse. So I need to find this. I can use Pythagorean theorem to do that. That would be 12 squared plus 5 squared equals c squared. That's 144 plus 25 equals c squared. That's 169 equals c squared. Take the square root of both sides, and we get c equals 13. So this hypotenuse is 13. When we ask for the sine of theta, that is opposite over the hypotenuse. So sine of theta equals opposite over hypotenuse. And I failed to mention that since we are in quadrant 3, the sine is negative. Sine and cosine are negative, so this needs to be negative 12 over 13. Okay, if cosine equals 3/4, so in other words, cosine is positive, and sine is negative, find tangent. So sine is negative here and here. So sine, sine is negative in these two quadrants. And cosine is positive in these two quadrants. So where both of these are satisfied would be in quadrant 4. So we're going to go to quadrant 4. And we're going to draw a reference triangle. Cosine of x, remember this is adjacent over hypotenuse, so COA. So that 3 is my adjacent side to this angle. And my hypotenuse is 4. So now I want to find y. Now, tangent, tangent of x here, remember this is all students take calculus. Cosine's the only thing positive here. So our answer is going to be negative. I'm going to go ahead and write that so I don't accidentally forget. But once again, to find tangent, I need to know that opposite side. So in order to find that side, I'm going to use Pythagorean theorem again. So this is 3 squared plus y squared equals 4 squared. That's 9 plus y squared equals 16. Y equals the square root of 7. So the tangent is opposite over adjacent, so the tangent of theta is negative square roots of 7 over 3. Couple more here. An angle in standard position has a measure of 137 degrees. I'm going to stop right there and go ahead and sketch my angle where that is. A point O is at the origin, P is the point on the terminal side, so we're looking at this. What are the coordinates? So we want to know what X and Y are if the hypotenuse is 12. So this angle right here, we need to find what that is. We know that this angle is 137 degrees. To find that other angle, we're closest to 180. So how far away is 137 from 180? That's going to be 43 degrees. So this is 43 degrees. Now we have an angle and we have a side, the hypotenuse side. So we're trying to find an ordered pair, which means we want to find this and this. So we're going to have to do this twice. Use trig ratios twice. It doesn't matter what we do first, but either way, if I start with y, I'm going to go opposite over hypotenuse, and so that would be so katoa. So that so part is the sine of 43 equals opposite over hypotenuse, and I'm going to solve for y. Make sure that we are in degree mode, and y is going to be sine 12 times sine of 43 degrees, which is 8.184 if I round to 3 decimal places like this says. And then to find cosine, you don't want to use Pythagorean theorem here and take your rounded answer and plug that in. So we're just going to use trig ratios again to get a more exact number. So that was to find y. To find x, we're going to use adjacent over hypotenuse because that's the adjacent side. So I'm going to have the same thing, cosine of 43 degrees equals adjacent now over the hypotenuse, which is 12. And I'm going to multiply both sides by 12, type that into my calculator, and I get 12 cosine of 43. Once again, making sure that I'm in degree mode, I get x equals approximately 8.776. So my ordered pair here should be negative 8.776 because in quadrant 2, x is negative and y is positive. So once again, we always have to make sure we think about that. All students take calculus. Where are we positive, where are we negative? Cosine is negative in quadrant 2. Sine is positive. And this would be 8.184. This is our ordered pair for this. That's this point up here. Okay, last one. Given that theta is an angle in standard position, point O is the origin and point P37 lies on the terminal side, find the length of OP. So 3, 7, I'm going to draw a reference triangle. That's going to be in the first quadrant, 3, 7. This is going to be 3, that's going to be 7 to find the hypotenuse, the length OP. If this is P and that's O, I want to find the hypotenuse. So we can use Pythagorean theorem for that. We get 9 plus 49 equals 58. So we end up getting take the square root of both sides. We get the square root of 58 equals C. So this is the square root of 58. So OP is the square root of 58. Find the angle of that. So find the measure of this. I'm just going to use not the square root, so I'm going to find this, and since I have these two whole numbers, I'm going to do the tangent, and I'm using tangent because this is the opposite, this is the adjacent. You can use the square root of 58 if you want. I'm not going to do that. You can use any of those. We can use sine and do 7 over the square root of 58, or we can do cosine, which is 3 over the square root of 58. I'm just going to use this. Tangent of theta equals 7 over 3, which is opposite over adjacent. And remember, when we are finding an angle, we have to use the inverse of that. So we would say theta equals the inverse, -1, 7 over 3, and we would type that into our calculator. So second tan 7 divided by 3. And we should get an angle. How do I round this? I'm going to round this to the nearest tenth. So this should be approximately 66.8 degrees. And that is your review. I know it's a lot, guys. You can do it. You've been working hard, and you're about to have a well-deserved break. So try to make sure you ask questions as you have them. Hopefully this video has helped if you got stuck. Let me know if you have any questions.